A thin biconvex lens of refractive index 3 by 2 is placed on a horizontal plane mirror as shown. This is a plane mirror. The space between the lens and the mirror is filled with a liquid of refractive index 4 by 3. It is found that when a point object is placed 15 cm above the lens on film axis, the object coincides with its own image. On repeating with another liquid, the object and the image again coincide at a distance 25 cm from the lens. Calculate the refractive index of the another liquid which is there. You can solve by several methods this one. You can solve by several methods. So let me begin with this. I have a mirror. There's a mirror. Then we have a lens. This is silhouette. Then in between, okay, there's a lens. Some other color. This is our lens. Now the gap between the lens and the plane mirror is filled with a liquid. I'll choose this is the liquid. So this will behave like a plano-convex lens. The liquid blue color on what you see will behave like a plano-convex lens. Now we have kept an object so that the image will be formed there. Refractive index of this be mu1, mu2, that of the liquid be mu3. Radius of this curvature, let it be r, we don't know. Equiconvex, biconvex is telling, and this medium is air, no? We have this one. You can do one thing. This whole setup you should replace with a concave mirror. And if it is at a no, this distance is how much? 15 centimeters. Then this whole setup will behave like a converging mirror such that where the object and image should be at same point. So when it's possible at center of curvature. So what should be the equivalent converging mirror? That should be equal to the radius of curvature should be 15 centimeter. Then so we don't know radii and we know mu1, mu2, mu3. With that we'll calculate the arc. That is the one approach. Straight away you can go for refraction at spherical surface formula. Because what should happen to the ray after refraction? The rays after refraction from this lens and the liquid should be incident normally on this. I think this ray diagram is something very important. We'll undergo after refraction should be like this. Let me this diagram is very important. You can see clearly refraction. Now refraction will occur. After refraction here, it should be incident normally so that it will retrace path. I'll write it mu3 here. Okay, it will be incident normally on the mirror, it will retrace path. So first refraction at surface A, then at B will apply it. At A, this will be the refracted ray is in medium of reflectance mu 2, no? So this will be mu 2 pi dash minus mu 1. Everything I'll choose P center because it's thin lens. PO equal to mu 2 minus mu 1 by plus R. P1 will be minus 15. I'll substitute all this sign later on. Okay, then again at B, refraction. Now whether reflected ray in the liquid, mu 3, and it should be infinity, no? Because after refraction should will become parallel. The final image will be at infinity. Minus mu 2 pi dash equal to mu 3 minus mu 2 by R. Adding up these two, minus mu 1 PO equal to mu 2 minus mu 1 by R. Adding 1 and 2, equation 1, this is 2. Adding 1 and 2, adding 1 and 2, so this will be mu 1 PO mu 2 minus mu 1 R. PO, this will be mu 1 is 1 minus 15. Refractive index mu 2, how much? 1.5. So mu 2 1.51. The value of R with this R should be positive. This mu 3 is how much? 4 by 3 minus 1.5 by minus R. Solving this, we'll get expression for R. Why negative sign? The radius of curvature, this is minus R. Or here only I'll write it minus PO plus R. I think this would be a better idea. Solving this, we'll get expression for R. I need the value of R. 10 centimeter. No. Again, we'll change this. Same diagram. Now, another liquid is brought here. On repeating with another liquid, the object and image again coincide at a distance 25 centimeter from the lens. The same situation, it will be 25 centimeter. Second situation, this will be 25. The liquid here will be some other liquid will be. I'm changing color. Earlier it was blue, no? Now it will be green color. We have to calculate the refractive index of this liquid. Mu 4, I'll write it. Mu 1 as usual, this will be mu 1, this will be 25. So again at A, I'll write it here, mu 4. So this is at A, then again mu 2, pi double dash, some image here. Actually, it should be same. So let me write pi dash only. Mu 1 minus mu dash. Some other position. It should not be same thing. No? Dash equal to mu 2 minus mu 1 plus 1. Then at B, mu 4 by infinity minus mu 2 minus 1. 3 and 4. This will become minus mu 1 minus po dash we know all values, so we have to calculate mu 4. Let me do the calculation part. Now mu 1 is 1, po dash is minus 25, mu 2 1.5 minus 1 plus 10, mu 4 we don't know, mu 2 1.5, this is minus 10. 1.6 will come. What is the other approach? I said we have other approach also. This everything you should replace with a, the other approach I'll show you. I'll bring to the next page. What is the other approach? See, nothing wrong. You should analyze. You should analyze the different methods. It's not that you should think in this way only. What is the other approach? If this is the lens, so what you can do is like, you can replace this everything by such that it should be at the center of curvature of it, so that object and image will be there only. Then use formula, silver lens formula. Take help of this silver lens. Then find out the equivalent focal length. First you calculate focal length of this and this. So 1 by f2, 1 by f3 will be equal to 1 by fl. Focal length of mirror is infinity. Then 1 by f should be equal to 1 by fl minus 2 by fl. This is what that is. Focal length of this should be equal to 15 by 2. If object is at center of curvature, image will be at center of curvature only. So now you know f, you know fm will be infinity. Then you know what is f2. What is f2? 1 by f2 is equal to mu2 1.5 minus 1 1 by r minus 1 by r. Okay, that F2 will come here. We know F2 will come. And what is F3? F3 we have here. 1 by F3 is equal to mu3. Refractive index is 1 point theta. Mu3 is 4 by 3. Sorry. Plano concavities. Fine. So you know F3, you know F, then substitute here using this formula. You will get R. Then again proceed in the similar way. Okay, fine. This will be lengthier. What method I earlier shown, that will be much easier. This will be lengthier one. Or you can use this method also. This is the equivalent concave mirror.